In this lecture, we will be talking about change over time and how to analyze change over time using some interesting statistical techniques, so working with diachronic data. And obviously, not all of you are interested in historical analysis of language, but these techniques can also be applied in different types of comparison. So I think they might be of interest to all of you. I would like to start with some light reading before we crack on with the equations here. This is a picture not taken today, as you can see, from sort of bedroom window from our house. And when you zoom in, you can see this and perhaps that, and you all are now familiar with this site already. And this actually inspired me to write the chapter in the book that deals with historical analysis of data, because, what is the better place than Lancaster in sort of the middle of all this history with the view of this beautiful medieval castle to think about diachronic data, historical data, and analysis of historical data. So I'll read you a tiny paragraph of what I wrote inspired by this, and I actually included a paragraph in the book itself, surprisingly, because this is not a statistical description or description of an equation by any stretch of imagination. So just bear with me just to soak up the atmosphere of this type of mind frame. I'm sitting at my desk. The weather outside is miserable. Great, we don't have it here now. Grey and rainy, but that's a sort of typical Lancaster scene. Through the window, I can see the medieval Lancaster castle on the hill, the priory, and the valley of the River Rhône, all in a foggy mist. Buildings, trees, and people have the same indistinct color. Only a flag with the typical Lancaster shade of red is flying from the castle, like a drop of paint which an artist has left unintentionally in the picture. My thoughts take me back in history, and I keep wondering about how color was perceived in the past. Was it connected with the same associations, sensitivities, and cultural frames? On a rainy Lancaster afternoon, I start searching the e-book corpus. Here it comes. 1 billion words of early writing provide a unique insight into the use of color words in the 17th century. I scribble notes, produce graphs and p-values, and here we start. Right. So we'll be talking about historical analysis, and a lot of these examples will be taken from the e-book corpus, a wonderful resource that is available to anyone interested in historical analysis of English that starts in the 17th century. There are some sort of pre-17th century, but the bulk of the data is 17th century onwards. And there are some really interesting insights if you search the corpus. So before we look at the specific details of statistical analysis, I would again like you to turn to the people sitting around you and try to discuss these three questions. Which color terms are most popular, and we are thinking now? Does this change over time, do you think? How would you investigate that? So just have a go and go at this. 1 or 2 minutes. Okay, guys, I know that some of you are still discussing, but can we sort of return to a large group? And any thoughts on color? Because color is a very interesting cultural concept, isn't it? So any thoughts on color? Which color terms do you think are most popular? Any suggestions? Color names, yeah. Black and white, okay. Right, well, stylish colors. Any other terms that you think might be quite popular in red? Yes. Yeah, we have a lot of red around us here as well. Any other colors that would be? Okay, right. So sort of more general colors. Okay, brilliant. Any other thoughts? Do you think this changes over time? As anything, right, in language and culture and society. There might be sort of cultural preferences. Well, the corpus linguist in me would say, well, that's an empirical question. Right? And the answer is, well, let's have a look at the corpus and see what's happening there. Well, so how would we investigate that if this is an empirical question? Okay. Okay, all right, right. So we need to that's very interesting. Yeah. Ultimately, what we need to do is we need to look at a diachronic corpus, a historical corpus, but that we need to take all these considerations into account, the representativeness of the corpus over time, and so on and so forth. So let us explore some of these ideas and see how we would do that. So where to start? I like to start with pictures. So let's start with some pictures. And these are the pictures based on my investigations when I was sitting on this Lancaster rainy day, looking out of the window and nothing else to do but search a corpus. So there are two things that you can see here. One is a line graph and one is a candlestick plot. And as I said, with visualizations, we can be fairly creative, right? We want to find ways which help us display the content, which help us display the patterns in the data. The line graph is probably something very obvious. We have color terms, and we have on the x-axis, we have 1590 to 1690, so this span, this period of time in English history, and we have different spikes here in terms of the popularity measured by frequency per million, right? So this is not necessarily popularity of the color, but just the use of the color term in discourse, right, which can mean different things, and we need to look at the specific context as well, right? I also color-coded the colors that it becomes easier for us to see which one goes up and which one goes down. An alternative form of display would be a candlestick plot. I'm not sure how many of you have seen candlestick plot before. It looks deceptively similar to the box plot, but it is a very different one, right? A candlestick plot hasn't been used in corpus linguistics before, I think. It is used usually in marketing and development of stocks on the market and all that, right? So in a very different field. And I've just borrowed this candlestick plot to show something interesting about corpus linguistics. So how to interpret the candlestick plots? Candlestick plot is really helpful if you have some diachronic data, so development. And the development can be over a period of a day. This is what you see when the markets don't go up or down, right? Or over a century or two, right? So it doesn't matter. You need to have some ordered data according to the time. You have here the different color terms and boxes, so the candles, to use the metaphor, and the wicks associated with those color terms. In order to interpret those, you need to know the basic distinction. The distinction between those ones that declined and those ones that increased their frequency, right? And they are indicated by a filled box, the first ones, where we have the first value here, it starts here and it goes down, right? So the solid box is the decrease over time, whereas the empty box is the first value starts here and then it goes up to there, right? So the first two things that we see over a period of time is where we started and when where we ended up in terms of the frequencies of whatever we measure. Here we measure the frequency or relative frequency of the color term being used in discourse. Right? These wicks also give us an indication throughout the process whether something happened there, whether there were some spikes and then it went down. So it gives us the maximum value and the minimum value, right? And of course, if the maximum value is at the end and the minimum value at the beginning, there are no wicks, right? So you can actually see, it tells a story. This simple candle tells a story about the development over time. It is a very nice summary. Okay, does that make sense? It's an explanation of the graph. So we have the graph, and now let's explore the notion of time from the statistical point of view, because any diachronic or historical analysis has time as its major variable, and time is a very interesting, specific variable. Right? It is from the statistical point of view, it is a continuous scale variable. Right? This means that we can measure time on a continuum of centuries, decades, years, months, weeks, hours, days, seconds, milliseconds, depending on the granularity of our research and the precision. Right? If we have Twitter data, we can even have sort of seconds or minutes. Right? If we have diachronic data, like the data in the EBO corpus, we might be looking at decades or years. Studies involving time as a variable are diachronic studies or longitudinal studies, right? Study of a variable over time. And what we want to be investigating is both the change over time in language, discourse, and usage, but also stability over time. And this is really important to stress, right? Because very often, and far too often in corpus linguistics and in statistics, we focus on differences, right? Comparison, and it's always so comparison leads us to differences and we report those. But the stability is very interesting as well, so we shouldn't forget about that, even in the diachronic type of analysis. So we are dealing with diachronic corpora, and we talked about corpora and their representativeness, but we were thinking about corpora representing a particular state of language at a particular point in time, right? And the notion of representativeness is already complex in synchronic corpora. When you add the variable of time, then it becomes even more complex, because we need to guarantee something that I call diachronic representativeness. So the corpus composition, ideally, if we can afford that, would be similar over time. So we are comparing like with like, right? We are not comparing different sampling strategies at the beginning, middle, and end of the corpus, right? So we are not getting results due to sort of changing method, but we are able to see how language changes in the same segment of society, the same segment of language, same register, genre, text type. Right? However, we have to relax this criterion a bit, because what we know about language is that it is so constantly developing, and the genres, registers develop with language. Right? So there's a constant fluidity. New registers like scientific writing, think about 17th, 18th century. This is a prime time for the rise of the scientific writing, which wasn't available before. And with diachronic data, we also have to, what Terttu Neverlainen calls, make the best use of bad data. Just the data that is out there, right? We can't go back in time unless we invent a time machine and ask the speakers or collect more data, right, from the history. We are also dealing with a phenomenon that is called diachronic polysemy, right? The same words, the same types have different meanings over the period of time. So if we are just searching, well, just give you the pre-2000 meanings of web, tweet, and cloud, yeah? We were talking about spiders, birds, and the skies, right? Nowadays, the default meanings that probably get activated are obviously the online meanings of these words. And this is just in our lifetime, right? Think back centuries. So that's why measuring time using simplified graphs like these, men go down, women go up, whatever that means. Right? This is the sort of, the cultural-nomic type of approach where you have a large data set, a corpus, if you call it corpus, that changes its representativeness over time. You have no access to the context, and you just look at the top level of abstraction. And when I look at a graph like that, my only conclusion is I can't interpret it. I can see what is happening, and I'm not questioning the reliability of the findings. I'm questioning their validity. Right? What is the relationship between the social reality and a finding like this one? Okay, so what are the tools that statistics offers us for looking at diachronic data? And some simple ones and some more complex ones. So let's start with the simple ones. Percentage change, and then a statistical test that uses inferential statistics called a bootstrap test, a very interesting test that hasn't been used that much in corpus linguistics, but is a sort of great example of this new method called bootstrapping, but I'll explain that in a minute. So first of all, some real examples. In this table, I have 3 linguistic features, or rather 4. Its, must, time, and pestilence. Just, randomly selected words, and I was interested in their use in the 17th century. And 17th century, especially the latter half of it, in English history, if you know a bit of English history, was a sort of period of a lot of turmoil. You have the Commonwealth and Protectorate, that's Oliver Cromwell, and then you have the restoration of monarchy. Right, so the king is first beheaded, and then the monarchy is restored. Right, quite a unique event in British history. Never happened again after that point. Right. So we know that on the backdrop of history, there's lots of things going on in the society. A lot of social processes, a lot of social and political changes. But just language change as well. Right? So some grammatical words and some content words here. And what we can do very easily is to take the measurements at one point in time and take the measurements at another point in time and compare them, very simply, just to see whether there is any potential for development. Obviously, then we need to interpret it carefully. Right? What we can calculate is the sort of percentage increase and decrease, and anyone can calculate that very, very easily. You take the second measurement, subtract the first measurement, divided it by the first measurement, and multiply by 100 to get the percentages. Right? And this is how I computed the percentages. Just now looking at the first value, 27%. So 27% increase, because I have the plus sign here, right, rather than decrease in these two cases, right? So these are the values taken directly from the table that I plugged in and got this very simple equation and then this result. So when you are looking at these changes, you can quantify or start quantifying what is happening there. over a period of time and whether there are some changes. Obviously, you don't know whether something happened in between these, right? So it's a matter of granularity also to select points in time and select them wisely. Here I selected them based on my previous knowledge of British history, because I think something interesting should be happening or might be happening there. Right, so what is the situation? Okay, going beyond percentage change, because this is the basic descriptive statistical technique that you can use, and moving on to what we call a bootstrap test. And bootstrap actually is a sort of metaphorical language applied in statistics, and it really sort of metaphorically refers to bootstrap and the expression to pull oneself by the bootstraps. So you get out of the sort of situation and using your own resources. So bootstrapping procedure in statistics is relying on the sample rather than going out and resampling. And this is especially relevant in diachronic analysis, because as I mentioned, it is not possible to go out there and collect another sample. So you have to rely on the resources that are available. And this is exactly what bootstrapping does. That's why I'm mentioning it in connection with diachronic analysis, although bootstrapping has been used widely in other areas of research and statistical analysis. Right. So the bootstrapping process, as this explains, is a process of multiple resampling. So you rely on the same sample, but you resample it multiple times internally. And I'll explain what this means in a moment. So thousands of times, this is like a experiment that a computer runs with replacement of the data. So imagine your texts in a corpus being in a hat. You pull them out of the hat randomly, but you pull one, look at the value of the statistic you are interested in, and put it back in the hat. So this is with replacement. You always have put it back. So you draw the text, look at the value, put it back in the hat, and just start again with random sampling. Right? I'll show you in a moment. So some texts are represented multiple times in the resampled version. And again, there's some mathematical theory behind that, how this helps us. So this means we take a random sample of text from the corpus in such a way that each text can occur multiple times in the sample, because we place it back to the pool from which we are sampling. Right. Once it has been taken, each resampling cycle, we note down the value of the statistic, such as the mean frequency of a linguistic variable, and that we are interested in, and this gives us an insight into the amount of variation in the data and gives us confidence to generalize from this sample. Right. So the reason why we are doing this is to get confidence to go beyond the sample. Right. So we use the variation that is inherent in the sample to go beyond the sample, and we use this through computational simulation. Okay, this is what it looks like in real life. So imagine a corpus, a tiny one, that has only 5 texts, A, B, C, and D, D and E. Right, 5 texts. So this is our original corpus. This is where we start. We are measuring frequency of a linguistic variable. Think of a color term. Right. 10 in corpus A, 5 in corpus B, 15, 1, and 20. Right. So quite a lot of variation. Right. We can compute the mean, and this is actually what we are interested in, and most of the standard statistical tests work with the mean as our sort of value that we take as representing a larger group. Right? And we talked about means as the sort of measures of central tendency. Here starts the fun. This is the resampling bit. Right? The computer then runs this resampling procedure with replacement. So we replace the text back to the pool. So you can see that in this first cycle, we have text 2 represented twice. Right? Text B1s, D and E. right? But we are missing text C, right? So it didn't get into the sample. Just by chance, we do random sampling in each cycle, right? But we take the mean value of those that are available, right, in the sample. We do that again and again and again, and thousands of times. What we are really interested in is the distribution of this statistic. Because the distribution of the statistic, and again, as I said, there's mathematical theory why this works, is very interesting because it gives us some kind of information about how stable or unstable the measurement is. Right? So we can be confident to generalize beyond the sample based on the information that this computational simulation represents. So just if you were wondering what the equation is, and again, feel free to completely ignore that. If you are still wondering and insisting on knowing the equation, it is in chapter 7 of the book. What is important to know is that the bootstrap test outputs one statistic, and that is the p-value. Right? And we know how to interpret the p-value. The p-value, if it is smaller than 5%, 0.05, then we are happy to celebrate right articles, right? So this is the statistically significant option. In order to get to the p-value, we have to sort of plug in the numbers in this equation, and there's a bit of complexity behind that. So I won't go into this, although when you read it, it is really, really straightforward. So the explanation of this equation is actually here. We could compare across a large number of bootstrapping cycles, and I've just explained what a bootstrapping cycle is. The resampled corpus 1 and corpus 2. So this is a comparison procedure between two corpora, right? So we do the bootstrapping for one corpus and for another corpus as well, right? So because we want to run a comparison. So bootstrapping cycles of the resampled corpus 1 and resampled corpus 2, and look at a consistent difference between the resampled corpora, which would produce a low p-value, right? If there's a consistent difference, the p-value is low. That is, it is returned if all or most cases of resampled corpus 1 are either larger, and that's why in this process we add 1, or are smaller than corpus 2. In that case, we add 0, right? But if we have a mix of ones and zeros, then these will not be consistent, and the p-value wouldn't be small, right? And this is just the mathematical way of making sure that this happens, right? Again, you don't need to know the details. You need to know how the test is applied. So I can use the bootstrapping test to compare two diachronic corpora or two subcorpora in a diachronic corpus. All I need to know are the frequencies of the linguistic variable of interest per file, right, inside the corpus. So I need to have a list of files in corpus 1, list of files in corpus 2, and the frequencies, relative frequencies for comparison. Okay. Another technique, and as I said, I'll be just sort of touching upon those techniques, and if you are interested in more details, obviously we'll do a bit of work in the computer lab, but you can also read more about that if you are interested. So clustering analysis, and clustering analysis is really, really interesting. Clustering analysis helps us deal with multiple data points, and in this case we have data points across the 20th century, 1900 to 2000. So this is the 20th century. We have the years here. And we have frequencies of a linguistic feature. Again, we are measuring linguistic features across time. What we would like to know is whether there are certain periods that have a sort of prominently high frequency of those linguistic features. So categorize history using linguistics, if you like. So now we are not interested in the linguistic features themselves, but we are interested in categorizing the periods of time according to the linguistic features. So using linguistic features to see whether there were periods of time that have had prominent frequencies of these linguistic features. there are different clustering analyses, hierarchical agglomerative clustering and variability-based neighboring clustering, the VNC. And they are used in two types of research. The first one is the default one that we use when we don't have diachronic data. Because the standard procedure for creating clusters in linguistics and statistics is this, right? When we have the same data sets, in the first case, we would just go by similarity of values. So the first case would just cluster the values of the same, that are the same. So 40 would cluster together, 20 would cluster together, and 10 would cluster together, according to the frequency value, regardless of the period where these appear, right? So across the span. But this is problematic because we assume that time doesn't jump, right? But that time moves and the development of language moves throughout the time. And obviously it goes up and down, as we can see here. But we wouldn't be comfortable necessarily clustering across this. So what we need to do is to inform this clustering algorithm to cluster only those that are contiguous next to each other, right? Just add those that have some kind of connection in the diachronic order, how time passes. Right? So this is the difference between these two clustering algorithms, and that's why when we have diachronic data, we have to be mindful of the sort of another dimension, which is the time, that actually put some constraints on what we can do with the data. Again, this is something that Lancaster Stats Tools Online can do for you. So you just plug in your data and you will get the results of the neighboring cluster analysis, and that's a dendrogram, so a tree plot. This is a tree plot based on the same data set that I showed before. So this is the data set. This is the interpretation of the data set. The graph on the left is the traditional clustering algorithm that doesn't perform so well on diachronic data because it just jumbles the years. So just for, if you can see that, I have 1970, 1950, 1960, 2000, 1990, 1900, 1910, so all over the place. Right. Whereas this clustering algorithm would leave the time as is and create the clusters here. Right. So there's one cluster over here from 1900 to 1930. So this is an interesting period according to that linguistic variable. Another interesting period, 1980 to 2000 over here. Right? So we just keep that information together. Okay, finally, the final statistical technique that I would like to mention, and that's the sort of peaks and troughs analysis and usage fluctuation analysis that sort of go hand in hand. These are the techniques, and again, I won't go into the details, but I just want to show you the application and interpretation of the graph. So these are the techniques that produce a graph like this one. Right. Here's 1600, here's 1700 somewhere, and I can do it with frequency of any linguistic variable or any statistic. Right. So this is absolutely flexible in that sense. What you can see here are several things. First of all, you have data points across time. Right? So this technique plots the points, the frequencies, if you like, or comparison of frequencies across time. It also plots a non-linear regression model, right? The GAN model. We've talked about regression before, and we had some kind of simple examples of regression. This is a more complex example of regression because regression, generally, the simple model, assumes a linear relationship. Remember the regression line that we looked at when we looked at the correlation between two variables, there was always a line. However, we know that historically, language doesn't develop in a straight line. Right? You have these peaks and troughs, and that's why we call this peaks and troughs. You have an increase followed by a decrease, and again an increase in another period, especially if we are interested in discourse analysis and development of lexical items over time. Right? They are frequent in one period, then they diminish, and they might be rediscovered. Right? So that's why we need a curve, not a line. Right? So that's all there is behind this, so non-linear regression model. The computer knows what the equation is. And we have 95 and 99% confidence interval. So the darker area inside around the curve is the 95% confidence interval. And if we want to be even so more precise, we have the 99% confidence interval. And again, we talk about the confidence intervals. We can build them around single points, but we can also build them as these sort of shaded areas around a curve or a line. And we have also significant outliers, because what we can tell about these points are they are outside of the confidence interval, so they stand out. Right? And in statistical terminology, we talk about significant outliers that are outside of the bounds of the 99% or 95% confidence interval. So what I'm displaying here are results of the analysis that is looking at the associations of the word red in discourse using collocation analysis. So it combines collocation analysis, so the associations of the words across time, and whether this changes or not, and how this changes. And this is what we call the usage fluctuation analysis, how the usage fluctuated, how it changed over time. So there are a few steps. Again, I won't bother you with the details. Lancaster Stats Tools Online can perform this type of analysis for you and produce these graphs very easily. So a few things to remember. When we look at historical analyses, because we use the data that is available, it is imperfect data. Well, any data is imperfect, but when we go back in history, then we don't have that much choice of creating the perfectly random sample, and so on and so forth. So what we really have to be doing is being critical about what data we have and what this can tell us and what this cannot tell us, right? The limitations of the analysis. Thinking about diachronic representativeness and alternative interpretations of linguistic development, and also fluctuation of meanings across time. Visualization options, and we have multiple graphs that we can use. I've shown some of them. The candlestick plot is a favorite of mine, but you might have different favorite graphs. Bootstrapping tests I mentioned as an option that is very useful in corpus linguistics, and the peaks and troughs analysis and the usage fluctuation analysis as well. So that's all from this lecture, and hopefully we'll be able to apply some of that in the computer lab, and there will be also time for your individual projects. So thank you.